Astronomers are looking deeper into the early universe than ever before. The expectation seems straightforward. Find the first galaxies, and you find the first major structures in cosmic history. But a different possibility has been sitting in the background for decades. While telescopes collect light from some of the earliest visible galaxies, researchers keep comparing those observations against long-running simulations. Those simulations point towards something unsettling. They suggest that large gravitational structures may already have existed before any stars ignited, before any galaxy lit up the darkness, before there was anything visible to observe at all. That changes the picture immediately. The first galaxies stop looking like builders. They start looking like occupants. What appears in the telescope may not be the first architecture of the universe. It may only be the first architecture that produced light. If that prediction is correct, then the visible universe is not where cosmic structure began. The earliest galaxies may have emerged inside a framework that was already there, hidden from view. Which raises a difficult question. How do you test whether something invisible built the stage before the lights ever came on? Simulations begin running the clock forward from the early universe. Again and again, the same pattern appears. Long before mature galaxies fill space with light, vast gravitational networks start taking shape. Matter gathers, dense regions emerge, connections appear between them. The framework keeps growing even though almost nothing visible exists yet. That creates a problem for the simpler picture. If galaxies built everything from scratch, then removing the galaxies should remove the structure. The simulations keep producing the opposite result. Instead, the simulations keep producing something that looks more like prepared ground before construction begins. The visible objects are no longer appearing first in the sequence. The framework is, run the simulations again. The outcome keeps returning. The structure appears first. As the networks form, they create locations where later structures can emerge. The idea that visible matter organized itself naturally begins losing ground. A different possibility keeps surviving each run. Galaxies may not be the original builders at all. They begin to look more like occupants moving into a landscape that already exists. That does not prove the landscape was real. The simulations are still predictions, not confirmation. But if an invisible framework formed first, it leaves behind a new challenge. When astronomers look toward the earliest galaxies that can actually be observed, should any trace of that earlier structure still be visible inside them? A new generation of observatories begins looking directly into the period where these predictions matter most. The distant smudges that once marked the limit of observation start giving way to actual galaxies from extremely early cosmic epochs. Objects that previously existed only as points of speculation now become visible targets. Among those observatories, James Webb pushes deeper into the early universe and brings those targets into view. That changes the situation immediately. For years, the invisible first framework lived mostly inside simulations. Researchers could compare models against later cosmic structures, but the earliest stages remained largely out of reach. The crucial era sat beyond direct observation. Now the gap begins to close. The galaxies are no longer hidden behind the limits of older instruments. For the first time, the prediction and the observation are occupying the same moment in cosmic history. Predictions can be placed beside observations. The framework can be tested against real objects, rather than inferred from distant consequences. For the first time, the process starts to feel straightforward. If the simulations have been pointing in the right direction, then traces of that earlier structure should begin showing up exactly where astronomers are now looking. The oldest observable galaxies are moving from mystery to evidence. All that remains is to see whether they appear where the framework says they should. The comparison finally begins. The simulations predict an invisible framework. The telescopes reach back far enough to inspect the era where that framework should be shaping the first galaxies. For a moment, the path ahead appears clear. Then the observations start arriving. Some of the galaxies refuse to cooperate. They appear brighter, more massive, more developed. They look further along than many of the timelines expected. That immediately changes the task. That immediately changes the task. The question is no longer whether an invisible framework existed. The question becomes whether the simulations are describing its effects accurately. Researchers return to the models. Timelines are checked. The comparison that looks straightforward begins getting messier. The comparison becomes more demanding, because the observations are no longer matching the expected picture as neatly as before. The pressure shifts. A framework can exist and still produce predictions that miss important details. That distinction suddenly matters. The early galaxies remain visible. The simulations remain valuable. But the confidence that both should align cleanly begins to weaken. What once looked like a straightforward confirmation starts becoming a more complicated investigation. The invisible first picture survives. The certainty does not. Now a different problem emerges. If some of the earliest observed galaxies are not behaving exactly as expected, then what are astronomers actually seeing when they look into the dawn of cosmic history? Astronomers keep pointing telescopes toward the young universe. Each new galaxy that appears is more than another distant object. It becomes a measurement, a comparison, a test. Researchers are no longer looking only for ancient galaxies. Every new galaxy becomes a clue about something older than the galaxy itself. That changes the stakes. The first chapter of cosmic history is no longer defined only by the appearance of stars and galaxies. It depends on whether those visible objects reflect an earlier architecture that telescopes cannot directly observe. Every new observation pushes the comparison further. Some predictions hold. Others require adjustment. The process continues as astronomers measure where galaxies appear, how they develop, and whether their behavior matches the framework suggested long before these observations became possible. The debate gradually shifts. It is no longer centered on the first galaxies themselves. It is centered on what may have arranged the conditions for those galaxies to exist. Future observations will continue testing how much of cosmic history was already taking shape before light revealed any of it. Because the deeper possibility remains the same. The first known structure in the universe may not have been a galaxy. It may have formed before the first galaxy, before the first star, before anything could be seen. The visible universe may not be the beginning of the story. It may be the evidence that something older was already there. The first structure in cosmic history may never have been visible at all.